All right, write the b-value for each given percent increase or decrease. What we have to remember is the b-value, if it's greater than 1, is an increase. If it's less than 1, it's a decrease. So if it's a 21% increase, 100% is the same as a 1 as the decimal form. So if you take 100 plus 21, we get 121%. But we have to convert that to a decimal for our b-value, so we divide it by 100, and we get 1.21 as our b-value. And so for b, it's also an increase. And you may not need to do that math right there, so you may be able to just go ahead and say 1.05 would be our multiplier. Now on a decrease, it's going to be less than 1. So if you take 100% minus 1.5, we get 98.5%. If we divide that by 100, we get a multiplier of 0.985. So doing this, using the same idea for a 17% decrease, 100 minus 17 is 83, so the multiplier would be 0.83. All right, looking at number 2, determine the percent of growth or decay. And so as in the previous problems, you see when the number is greater than 1, it's a percent increase. Well, how much more is it than 1? Well, if we take 1.07 minus 1, you get 0.07. So 0.07 is the decimal form of the percent growth. And so if we multiply this by 100 to convert it to a decimal or a percent, we get a 7% growth. And the same thing for your next one, but we see it's less than 1, so we know it's decreasing. So if we take 1 minus 0.955, we get 0.045. And after multiplying that by 100, we get 4.5%. And this is going to be decay, as this one here would be 7% growth. All right, so number 3. I've talked about this in class about expectations. If you're going out to dinner and you're paying for your meal and you're going to leave a tip, you can expect the final bill to be more than what your initial bill was. So, and we have to use the ideas that we looked over in problems 1 and 2, where we're converting our percents to decimal form for our multiplier. So on this first problem, you have a $35 bill. You know you're going to pay 100% of that $35, so that's where this 1 comes from. And then you're going to pay 22.5% more, so that's where the 225, okay, that's 22.5% converted to a decimal added on to our 1. We don't need an X because we're not going to do this multiplication multiple times. And you put this in your calculator, we get 42.875, which would round to 42.88. Okay, number 4, you're getting 35% off. You should be expecting to pay less than the initial value of the meal. And so if the initial value is $10.50, you're going to pay less, but you are responsible for the remaining part. So if 35% is what you're getting off, you're going to be responsible for 65%. So if you had 100 minus 35, we get 65. So you're paying for 65%. As a decimal, that is 0.65. When we multiply that, we get 6.825, which we could approximate as 6.83. All right, number 5. And if you're looking at your paper version versus this video, you can see that I've already corrected the 1990s. All right, so writing an equation to model the cost of the hospital care in 1990. So in 1990, we need to know the initial value. It was $968. And it says that it increased by 4.25%. This is one people tend to struggle with. So you may want to go ahead and convert that to a decimal by dividing by 100. And in doing so, you get 0.0425. And so you're going to pay 100% of the $968 because it's growing every year. And you're paying an additional 4.25% for every year since 1990. So 1.0425. Now this one we do need to the x because we're going to be doing this over multiple times. Now one way to make this maybe a little easier is to say x minus 1990. So we can actually put in the year in the next step for whatever year you're trying to calculate the cost of the hospital care since 1990. So this next one, 968 times 1.0425 to the 2020 minus 1990. Now some of you, you can go ahead and just put 30 in there if you want to, because that's what the 2020 minus 1990 is. But some of us may feel more comfortable doing 2020 minus 1990 in our calculator. And in doing so, you get $3,374.09, and that's already a rounded answer. All right, so FM School District has 3,000 students, and it's declining by 6% a year. So if they're losing 6% a year, their remainder is 94% of their students. So 3,000 times 0.94. 0.94 is 94% as a decimal. And we do want this to the x because it's happening over a period of time, multiple years. And so we're going to do 3,000 times 0.94 to the 3, which gives us 2,492. And that's actually was 91 point something, but you can't have a fraction of a student, so we're just round that up to 2492. All right, number seven. Number 7, we're talking about, and this is the big thing between this problem and the previous problems, is it says compounded. And so whenever we're compounding, we're going to use this equation. A equals P times 1 plus R over N to the NT. Now R is going to represent your interest rate, but it's going to be the decimal form. So the initial amount on this charge is $17.50. That's what P represents. And then you have 1 plus, and we're going to convert this interest rate, 12.5%, into a decimal, which is 0.125. And again, we do that by dividing by 100. All right. How often is it compounded? Monthly. Well, that'd be 12 times in a 1-year period. And how do I know it's a 1-year period? Because this is an APR, and the APR stands for annual percentage rate. And then we're going to raise that to the NT. N, again, is the same thing here and here. And so 12, and T represents time. So how long is this going to go on for? For 2 years. And so if you want to put that in your calculator as 24, you can. Some of you may feel more comfortable just writing 12 times 2. So when you calculate this in your calculator, we get $2,244.14. All right. Number 8, you have a $2,500 college fund, and it's paying 5% interest compounded semi-annually. Semi-annually means twice a year. So we have 1 plus, and again, our R, okay, has to be a decimal, so you have to divide that by 100. In doing so, you get 0.057. So 0.057 over 2 raised to the 2 times 5, because 5 years. All right, and we have to do that 10 times because semi-annually means twice a year. And so in a 5-year period, it would have happened 10 times, twice a year, 10 times over a period of 5 years. And we calculate this in our calculators, we should get $3,311.18. Okay. Number 9, we start off with $1,500 in a savings account. It's paying 3% annual interest, compounded quarterly. Quarterly means 4 times a year. So you're not going to get charged interest, 3% interest, all 4 times. You're going to get charged 1/4 of that 3%. So again, we use 1 plus, convert this to a decimal, 0.03 over 4, and then 4 times 25, because it's over a 25-year period. And when calculated in the calculator, you should get $3,100 $66.63. All right, on to number 10. Now, you have to pay attention when you read all of these problems. If you notice in this next problem, it says continuously. And so in class, we talked about this. When it's continuously, all right, an infinite number of times, there is a limit to that, and we talked about the number e. And so the equation we use for this is a equals p times e to the RT. And if you forgot on your calculator, the e is from the second, you push the second key and then division. All right, so P is still the initial amount, and so the initial amount was 7,000 times E, and our interest rate, okay, it's still the decimal form, so 4% a day, you're going to convert that 0.04. You don't have to worry about adding it to 1 or anything else, just put the R value up there, 0.04, and then T still represents time, and so time was 5 days, so we put a 5 in, and then we calculate that in our calculators, and we should get 8,549.82. All right, number 11. Let me fix that 8. Number 11, you have half-lives. The half-life of BC17 is 3 hours. Don't go asking your chemistry teachers. I just made that up. All right, so BC17 is the half-life is 3 hours. It means every 3 hours there will be half as much left. And so we're multiplying by a half. Well, in a period of 1 day, how many times does 3 hours occur? Well, a day and hours are not the same units, so we convert the day into 24 hours. So there's 24 hours in a day. How many times does 3 hours occur? 8 times. So our 200 grams gets multiplied by a half 8 times. And so when we calculate this, we get 0.78125. And I just left it as all those decimals because it terminated after 5, and that's actually a nice decimal. All right, so in number 12, we're looking at this equation, and we have to determine how much is it growing or decaying. Well, in the equation that we looked at recently, the continuous growth, A times P times E to the RT, R represents the rate of growth or decay. And since 20.25 is less than 1, we know that it's decaying. And 0.25 would have been given to us, and we would have converted it to a decimal, so it's decaying at a rate of 25%. How much was there initially? Well, that would be the p-value, and so there was 200 initially. And what does the E tell us? The E tell us that it is growing continuously. All right, so number 13. How much was the initial charge? 2,000. What is the interest rate? And we're going back again. We're going back to this equation. A equals P times 1 plus R over N to the NT. And so what's the interest rate? Well, 0.11 would be 11%. How often is it compounded? That's our N. So it's compounded 12 times a year, or you could say monthly. How many times does this equation or how many years does this equation represent? Well, that would be our T, so 3 years. All right, 14. Find an exponential equation given the 2 points. In A, if you notice, we know when x is 0. When we know when x is 0, we know the initial value. And so I can go ahead and write y equals 200 times b to the x, because we know that a is 200. And then from there, I would just substitute in my other point for my x and y to solve for b. So 84.375 equals 200 times b to the 3. And to solve this, we would divide by 200 on both sides. In doing so, we get 0.42185 equals b to the 3rd. To get rid of the cube on the b, we take the cube root of both sides. And then taking the cube root here, we get b equals 0.75. So our answer to this equation is y equals 200 times 0.75 to the x. Now, there's other ways to find b, and you'll see that modeled in a couple of these next two problems. This is just one way of solving it. I've shown you multiple methods in class, and so if you feel more comfortable using a different method, that is fine. My main concern is you're getting the correct answer and you're not just plugging this in your calculator right now. Alright, so on B, we don't know the initial value, so I can't set it up like the previous problem, but I do have consecutive terms. And I know that because I see the x's are 2 and 3, they're consecutive, and if the terms are consecutive, all I have to do is divide my two y values. And we want to divide by the previous, so we're going to take negative 1029 and divide it by 147. In doing so, we get a negative 7. And so now that I know the b, we can substitute this into our equation. So y equals a times negative 7 to the x. And similar to the previous problem, I would just substitute this information in. Either one of those points, I'm going to use the one with smaller numbers. So 147 equals a times negative 7 to the 2. We should know that negative 7 squared is a positive 49, so 147 equals 49a. Divide by the 49 on both sides to get a by itself. And so we get a equals 3. And so our equation for this one is y equals 3 times negative 7 to the x. And again, if you want to check yourself, you can always put that in your calculator and check your table and see if those points are part of the table. Alright, so for this next problem, we're going to do it similar to the second problem because we don't know the initial value. We're not given when x is 0. But these two terms are not consecutive. So an extra step that I have to take in this problem compared to B is that besides dividing the two numbers, we also have to do a root. And the root is going to be the difference of our two x values. So the math here is going to be 91.125 divided by 18. And let me caution you, you're not always dividing by the smallest number, okay? It's not based on the smallest number, it's based on which one came first. You want to divide by the one that came first. And I know that the 18 came first because the x is 2 versus the x being 6 with the 91.125. And so when we do this, we also have to take the fourth root. And that 4 comes from the difference of my two x's. And when we do this math in our calculator, we get a value of 1.2 or 1.5. And so just like in the other problems, we can set it up. Y equals a times 1.5 to the x. Substitute one of our numbers in. I'll use the 2 and 18 because they're smaller numbers. And so 18 equals a times 1.5 to the 2. And so 1.5 squared is 2.25. So 18 equals a times 2.25. We divide by the 2.25 to get a by itself. And we see that a equals 8. So our equation for this problem is y equals 8 times 1.5 to the x. And again, if you need to check yourself on this, just put it in y equals on your calculator and check your table. Alright, almost done. So number 15, the first question you always want to ask yourself is, can I write if I'm looking at my two bases, can I write 8 as a base of 2? All right, always ask yourself, can you write the bigger number as a base of the smaller number? And yes, we can. So 2 to the 4th equals 2 to the 3rd to the 2x. So 8 can also be written as 2 to the 3rd. To simplify the right-hand side, whenever you take a base to a power, we multiply their exponents. So we get 2 to the 4th equals 2 to the 6x. Now the bases are the same. We can just solve the exponents. So 4 equals 6x. Divide by 6 on both sides, and we get x equals 4/6, or 2/3, or 0.66 if you're calculating that out in your calculator. On B, we're already set up with the bases the same. So like the end of the first problem, all we have to do is set the exponents equal to each other. So 2x equals 4x minus 2. Subtract 4x from both sides, and we get negative 2x equals negative 2. So x equals a positive 1. All right. In C, first thing you ask yourself, like in A, can I write 27 with a base of 9? No, because 9 squared is 81, and so there's no way to write, and we're not trying to write 9 to the decimal, or a decimal number. So I then have to ask myself, can I write 9 as any other base? Yes, we can write that as a base of 3 squared. So since I can write 9 with a base of 3, can I write 27 with a base of 3? Yes, that would be 3 to the 3rd. All right, so now we have to simplify the left and the right to get rid of the parentheses so that we just have bases of 3. And so on the left, we get 3 to the 6x. And on the right, and this is where a lot of students make mistakes, is you have to distribute this 3 to both of those terms. So we get 3 to the 3x plus 9. And since we have the same bases, we can solve the exponents. So 6x equals 3x plus 9. Subtract 3x from both sides. And we get 3x equals 9. And so x equals 3. All right, and on to D. I would probably rewrite the right-hand side first. So 64x equals 4 to the negative 2. Anytime you have an exponent in the denominator or the numerator, if you move it to the other side, it changes signs. And we'll move it up to the top to get rid of that fraction. So I have to ask myself, can I write 64 as a base of 4? Yes. It's 4 to the 3rd. So simplify the left. We get 4 to the 3x. It's 4 to the negative 2. Set the exponents equal to each other. Divide by 3. We get x equals negative 2/3. All right, 16. I'm not going to write a context down, but just to explain this for you, if I'm looking at this, I need a context that begins with 200. I had 200 baseball cards. There were 200 fish. There was 200 of something. I had $200 in my piggy bank. Whatever it is, it needs to start with 200. And we have to understand that this represents 5% growth. And so in your context, you need to explain that there's 5% growth. So it's grown by 5. And the same thing on B. It starts at 1,000. So whatever your context is, there's 1,000 fish, there's 1,000 baseball cards, 1,000 whatever, okay? It needs to start with that. And then you have to recognize that this here is 15% decay or a decrease. And so whatever your context is, you start with 1,000 and it decreases or decays at a rate of 15%. All right, 17, we have some graphs. I do expect these to be accurate within reason. All right, so this first one, I scaled it by 40s are actually 20s, one every 20. Just numbered it every 40. And so it starts at 200. And it's multiplying by half, so we know that, I guess we got to scale the x-axis also. 1, 2, 3. So at 1, it would be 100. Half of 100 is 50. Okay, and that right there would probably be enough points. All right, we know, and we should know it's decreasing because the b value was 0.5 less than 1. All right, on the next graph, we're starting at 40, but you do know that you're multiplying by 2, so we're going to get an 80. So I'd probably count by something that's going to allow us to see those values. So if you want to count by 40s again, that would be fine. All right, so important, we start at 40. 40 times 2 is 80, times 2 is 160. And so we have those points. But also recognize here, and we got space, if you had a -1 here, half of 40 is 20. And so this here would give us a good set of points for our graph. All right, last two problems. We talked about this, that I gave you the example of Mario Brothers or flower power. So this is the power. And then this is the root. Power rhymes with flower. So that's above the ground. All right, so you have x to the second power and the third root. And then we have 7 to the third power and the second root. Well, you don't have to write a 2 here. Okay, a 2 doesn't need to go there. It's just assume that it's a 2 because you wrote the root symbol, and that's the smallest root that we take of any numbers. All right, in 19, you're going to write it back into the fraction form. So what power is x to? It's to the 9th power. And we need to know what root that is representing. It's the second root. Like I said in the previous problem, it doesn't need the 2 there for us to understand that it's the second root. And then b, the 5 is to the 4th power and the third root. All right, I hope this video helps.